A gram to gram limiting reactant problem is probably the longest problem that you would see on an assessment. For a gram to gram, the process is the same as the mole to mole limiting reactant, but you're going to turn grams of your given into grams of any product, and then you're going to turn grams of your second given into grams of the same product. So I gave you 100 grams of PbNO32. I gave you 100 grams of iron chloride. Which of those runs out first? Give yourself enough room to write out 2 gram to gram conversion problems. I started with 100 grams of PbNO32. This is going to be a long problem because it involves 3 additional steps. Let's turn grams into moles using the molar mass. There are 331.2 grams of PbNO32 in 1 mole. Now I can use my mole ratio. There are 3 PbNO32. It doesn't really matter what product you choose as long as you're consistent. I'm going to use the PbCl2, so the lead chloride. So there's 1 mole of lead chloride. And honestly, I just chose that because it was the easiest one to calculate the molar mass of. Let's turn moles of lead chloride into grams using the molar mass. There are 278.1 grams of iron chloride in 1 mole. So let's solve. Multiply across the top. 100 times 1 times 1 times 278.1. 27,810. And then 331.2 times 3 times 1 is 993.6. I'm going to divide those, so 27810 divided by 993.6. And I get 27.98, so I'll round that to 28 grams of PbCl2. Definitely running out of room here. Now you have to do the same thing with your second given. 100 grams of FeCl3, gram to gram conversion. Turn grams into moles. 162.2 grams in 1 mole. This is the molar mass of iron chloride. There is 1 mole of iron chloride for every 1 mole of lead chloride. And then finally, we're going to turn moles into grams. There are 278.1 grams of lead chloride in 1 mole of lead chloride. Multiply across the top. 100 times 1 times 1 times 278.1, 27,810. Multiply across the bottom. 162.2 times 1 times 1. And then divide. I get 171.5 grams of PbCl2. All right, so now I've done all that work. I can actually answer the question that was given to me, which wants to know which of these is going to run out first. Well, if I started with 100 grams of lead nitrate, I would make 28 grams of lead chloride. And if I started with 100 grams of iron chloride, I would make 171 grams of lead chloride. So I don't have enough ingredients to make that 171. That's not even possible. The most I could make is the 28 grams, which means that it was the lead nitrate that ran out first. So that's my answer when I ask for the limiting. I'm going to say that lead nitrate is my limiting reactant. We don't say that 28 grams of lead chloride is the limiting reactant. That is how much product you could actually form. The limiting reactant is which reactant ran out first. So in this case, it was the lead nitrate that ran out first. All right, let's run through question 2. How many grams of aluminum chloride? So this time I asked you the specific product that you want to form. So how many grams could form if I had 34 grams of aluminum and 28 grams of HCl? It's 34 grams of aluminum. I'm going to turn grams of aluminum into grams of aluminum chloride. There's 27 grams of aluminum in 1 mole. There's 2 moles of aluminum for every 3 moles of, or for every 2 moles of AlCl3. And then now I want to find the molar mass of AlCl3, which, give me a second here, 133.3. There's 133.3 grams of aluminum chloride in 1 mole. So to solve, I'm going to take 34 times 2 times 133.3. That's 900 or 9,064.4. Multiply the bottom. 27 times 2 times 1. That's 54. And then divide your two numbers. So 34 grams of aluminum would make 167.9 grams of aluminum chloride. Now we have to do that again with 28 grams of HCl. So 28 grams of HCl, the molar mass is 36.5. There are 6 HCl for every 2 aluminum chloride. And then the molar mass here, 133.3 grams of aluminum chloride in 1 mole. When I multiply across the top, 28 times 1 times 2 times 133.3, 7,464.8. Multiply across the bottom, 36.5 times 6 times 1, 219. And I'm going to divide those. So 7,464.8 divided by 219, 34.1 grams of aluminum chloride. So, to answer the question, well, how many grams of aluminum chloride could form? I could only make 34.1 grams of aluminum chloride. I don't have enough to make 167 grams, which means that the HCl is my limiting reactant because that is what runs out first.